Hi folks, I'm Mr. V, and today's lesson is from Illustrative Mathematics, Unit 5 on Solid Geometry, and we're going to do some practice with prisms. And I'd like to point out to you at the very beginning, I have this quote by Ralph Waldo Emerson: "That which we persist in doing becomes easier for us to do. Not that the nature of the thing has changed, but our power to do it has increased." So if you were to work on the problems that I've asked you to do and do the work, you get better at it. That's the bottom line. Now here we have prism practice. The objective is I can calculate volumes of right and oblique prisms and cylinders and figures composed up of prisms and cylinders. So for the Bellwork, let's see if I can make this where you can see it. It says you have this cylinder. We need to calculate the height of the cylinder, of this cone, height of this cone. If you don't know what to do, here's a hint. You're going to use the Pythagorean theorem. When you do this, you're given the slant height, which is this hypotenuse, 17.3, and we're asked to find the height. We know that a squared plus b squared is equal to c squared. This is my formula. So I have the hypotenuse is going to be the longest side. That'll be the c, 17.3 squared. That's going to equal to my height squared plus my base here of the triangle squared. Now to isolate the variable, I'll do the inverse operation. I'll subtract 6.5 squared from both sides of the equation. And I get my height squared is equal to 17.3 squared minus 6.5 squared. And I need to take the square root of both sides of the equation. Anything you do to the right side of the equation, you do to the left. I'm not going to take the square root of this piece and the square root of this, take the square root of the entire thing. When I plug that into the calculator, I have SQRT, 17.3 squared minus 6.5 squared, and I get 16.0. And notice that it's actually 16.032, but when I round it to the nearest tenth, this is my answer, and that will be in inches. Okay, this is rounded. I know it's equivalent to, numerically, to 16, but when you want it to the tenth of a decimal, the zero here is a significant digit. It counts, so make sure you include that. The second problem that we have is on this next page, and let's see if I can make this a little bit smaller. If I look for a hint here, we're looking for the height of this. This is an oblique cylinder, and the number I'm given, the 12, is not the height. That's going to be the slant height. To find this, I'm going to have to use my trigonometric ratios. So we have the sine is equal to the opposite, or let me just do this like there. SOHCAHTOA. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. And I taught you to label from this angle, this would be the opposite, and this would be the hypotenuse. So I'm going to use the sine because it relates the opposite and hypotenuse. The sine of 50 degrees is equal to the ratio h over 12. To isolate the variable, we'll do the inverse operation, multiply both sides by 12. And I get these two cancel. In my calculator, the height is 12 sine of 50, or 9.2 is my answer. And in the Desmos, if you type in your answer, 9.2 inches, and I submit it, it'll tell me if it's correct or not. Hope you appreciate the computation layer, the stuff that I've done to create this. Height is not drawn. You could draw it. 16.0 is rounded, and we share our strategies. Now, on this page, you're given 7 different figures. And which one of these would be the easiest for you to find? Which one of these would be the most difficult for you to find? The volume of. Here's the most difficult. And you're supposed to check these. And then on the next several slides, you're going to pick 3 of them, at least one from your least difficult list and one from your most difficult list. Now, to help you, I'm going to go through several of these questions here now. And so I'll copy this over to my whiteboard, and we'll do these one at a time. To find the area of the base, I have to do, it's an area of a triangle. This is a triangular base. So my volume is equal to the area of the base times the height. It's a prism. This area of the base is going to be 1/2 of the base of the triangle times the height of the triangle, not to be confused with the height of the prism, times the height. So I have 1/2 times 11 times 5 times 8. And this would be 1/2 of 8 is 4. 4 times 5 is 20. This would be 220. That's my answer. And that'll be centimeters cubed. When I type in 220 here, I should be able to go to page 22, I think it is. And you can see, not this one, sorry, 22. You can see I got it correct. Now let's go to the next one, page 16. And here we go. If I were to work through this one is this one's a bit harder. I need to know the height of this thing. I need to know how far up it is, this height. What I'm given is the slant height. The slant height is 10. So if I have this right triangle, and this is 40 degrees, and this is 10, I'm looking for this height. So I'll use my trigonometric ratios, SOHCAHTOA, and we'll try this. This is the opposite. This is the hypotenuse. So I'm going to use the sine again. The sine of 40 is equal to my height divided by the hypotenuse, was 10. Multiply both sides by 10 to isolate the variable. These two cancel. I get 10 the sine of 40. 10 sine 40. I get 6.43. My height is equal to 6.43. Now the volume is equal to the area of the base times the height. The area of the base is pi r squared times the height, because it's a circular base. So I have pi times 5 squared times 6.43. And we'll put that into the calculator. Pi is what I'm typing in to get pi times 5 squared times 6.43. And I get 505.0 when I round it to the nearest decimal. And I'll plug that number in. 505.0. Oops. 505.0. And when I go to check this on page 22, 17, 18, 19, 20, 22, you can see that B is correct. I'm going to go through each of these just because I told you I would. But here, the volume is equal to the length times the width times the height. So I have 10 times 7 times 5. 7 times 5 is 35, times 10 is 350. Of course, this would be feet cubed. When I type in my answer, 350 cubic feet, and I check it on page over here, C is correct. Now we'll do D. This one is a little bit more challenging than the previous one. I'll copy it over to the whiteboard and do it on the whiteboard. In this triangle, we need to know the base of the triangle, which we know, and the height. This is missing. We know the hypotenuse. So to find this, I will use our Pythagorean theorem. A squared plus b squared is equal to c squared. The c is going to be the 8 squared. This will be 7 squared plus my h squared. So my h squared is equal to 64 minus 49, which is 15. So h is equal to the square root of 15, which is about, let's see, how much is that? Square root of 15 is 3.87. So this is approximately 3.87. Now we can find the volume of the prism, which is the area of the base times the height. This is equal to a triangle, so it's 1/2 times the length of the triangle times the height of the triangle, or base times the base of the triangle times the height of the triangle, times the height of the prism. When I substitute the values, I have 1/2 times 7 times 3.87 times the height, which is 11. And I'll put this into the calculator. 1/2 times 7 times 3.87 times 11. And I get 148.995, or 149.0 when I round it to one decimal place. We plug this in to our calculator here. 149.0. And we'll check this on page 22. Sure enough, D is correct. To do problem E, this is relatively straightforward. I think that this is probably the easiest cylinder problem on the page here. The volume is equal to the area of the base times the height. The area of the base is going to be pi r squared times the height. So we substitute the values. We have pi times 20 squared times 15. And when I put that into the calculator, I have pi times 20 squared times 15. And I get 18849.6. And this, we plug this into our answer here. 18849.6 cubic inches. And our answer here is correct. Two more of these. F. Copy this to my whiteboard. And here, if you look at the triangle, it's a 30, 60, 90 right triangle. This side is 4. And I'm looking for the height here. I don't know what this is. Well, if I look at my model for a 30, 60, 90 right triangle, we have the shorter leg. The hypotenuse is double the shorter leg, and this is root 3 times the shorter leg. So I have x times the square root of 3 is equal to 4. I could have used, not the Pythagorean theorem, but I could have used my trigonometric ratios. Instead, I'm using my knowledge of 30, 60, 90 right triangles. X is equal to 4 divided by the square root of 3. So 4 divided by SQRT, 3, and I get 2.3. This is about 2.3. Now, why do I need this? Well, the volume, which is what we're looking for, is equal to the area of the base times the height. And this is a triangular base, so it's going to be 1/2 times the base of the triangle times the height of the triangle times the height of the prism. We have 1/2 times 4 times 2.3 times 6.5. And I'll plug that into the calculator. 1/2 times 4 times 2.3 times 6.5. And this is 29.9. When I put this into the Desmos, 29.9, and I check my answer on page 22, it's correct. The last one we have here is G, and this is probably the most challenging cylinder problem that we have, because you're given the circumference, and you might have to Google to find the circumference is equal to 2 times pi times the radius. If 4 is equal to 2 times pi times the radius, to get the radius by itself, to isolate this variable, I'll do the inverse operation. I'll divide both sides by 2 pi. And what is 4 divided by 2 pi? I don't know. I'll put it into my calculator. 4 divided by 2 pi is about 0.64. So this is radius is about 0.64. Why is that important? Well, the volume is equal to the area of the base times the height, which is pi r squared here. It's a circle times the height. When I substitute the values, I have pi times 0.64 squared times 2. And I'll plug that into the calculator. Pi times 0.64 squared times 2. I get 2.6 when I round it to 1 decimal. And we plug that into our Desmos here and check our answer. And sure enough, it is correct. Now, the remaining pages of this are interesting. There are some questions for you to do, and you can check this values of A, B, C, and D to see if it works. There's this tower, this Cayenne Tower, and there's some questions on it and some videos to help you with it. And then for the cool down, there's a lesson synthesis and a lesson summary. You want to read the lesson summary. It tells you that we use the formula volume of the is equal to the area of the base times the height, but sometimes you don't get the volume, the area of the base, or you don't get the height, and you have to do an extra calculation to find it. That's what the whole lesson here was for, just this prism practice. And consider this drawing. This is a cylinder, and it's missing this cube in the middle of it. So how would you find the volume of this piece? This is a composite, and you have to take the volume of the cylinder and subtract from it the volume of the prism. And this is something that you are capable of doing. Good luck and success.